Lesson 7.7, we're going to talk about surface area of pyramids. The idea is the same as what we did on the last lesson with the surface area of prisms. We're just going to break these pyramids up into separate sections, find the areas, and add them together. So it's really not much difference here. So it starts on page 429. We're going to go ahead over to the next page, 430. So example 1, Maxwell made a model of a house using a cube for the bottom and a square pyramid for the top. He wants to paint the top of the house blue to match the bottom of the house. 1 tube of craft paint covers about 20 square inches. How many tubes of paint does Maxwell need to cover all the faces of the top of his model? Okay, so you can look at the picture here. One thing when you guys are doing problems like this, just take one step at a time, okay? There might be multiple steps to do. Just don't get overwhelmed by all the information they're throwing at you. Just try and do one thing, and then once you get that, try and do something else until you get what you need. So you can see on the picture there, so what they did in the book here, they drew a net of that. You're welcome to draw a net if you want to, or if you can just tell from the picture what's happening. It is a square pyramid, it tells us, so we know all those triangles on the sides are the same. So one of those triangles we do half times 3 times 5. 3 is our base, 5 is our height. That'd be 7.5. And we have 4 of those. So you can either take 7.5 times 4, or like the book did here, you could just add 4 7.5s together. Okay, so that's our triangle part here. Would be 30 then. And then we have a rectangle on the bottom. Well, technically a square, so length times width. 3 times 3 is 9, which is 39 square inches. You might question on this one, why are we actually painting the bottom of this thing? And that could be a valid question. There is a little bit of overhang on the sides, so we'd probably want to paint like on the outer edge, probably the middle part of our base of this pyramid. We probably wouldn't have to paint it, okay? But you know, it becomes the question, well, how much overhang do we have? We could figure it out. It'd be a little more complicated, but basically, if the whole thing, including the whole bottom, is 39 square inches, we have 30 square inches for just the triangles. If 1 tube of paint is 20 square inches, we're going to need more than 1 tube anyway, just to do the triangles. Even with doing that whole bottom, that's still keeping us under the 40 square inches that we could cover with 2 tubes. And so either way, whether we paint the whole bottom or not, we're going to need 2 tubes of paint regardless. So 2 ways of doing this. One way, once you get the 39 square inches as your surface area, one option would be you could divide that by 20. 39 divided by 20. How many 20s do you need would tell you how many tubes of paint you need. It would be 1.95. Probably not going to be able to go to the store and ask for, 1 9/500 tubes of craft paint. They're not going to squeeze paint out of the tube for you and say, oh, I'm sure somebody will want that 500ths of a tube sometime. Okay, you're going to have to buy it by the tube and just have a little left over. The other option you could look at like I did over here on the side, you could say, well, 20 is for one tube. If we had 2 tubes, that would cover 40. That's more than 39, so 2 tubes would be enough. Look at the try it at the bottom of the page. We are being asked to do pretty much the same thing we just did on example 1. So we are finding the surface area of the square pyramid. Technically on this problem it says draw a net to find the areas of the base and each face of the pyramid. So since it said draw a net, we should probably draw a net. If they didn't ask me to do that, I probably wouldn't do it, but that's kind of a personal preference. Okay, so the net of this is going to look something like this, where you're just going to have a square in the middle and then these 4 triangles going off from that. And you could draw your dimensions here also. Okay, so that's kind of what we're looking at. So again, with it being a square pyramid, since our base, all 4 sides of the base are the same length, that's going to make all 4 of our triangles be exactly the same. So we could do our triangles. Remember our formula for the area of a triangle is half base times height. Probably not a bad idea to start out just by writing your formula, not rushing through this thing. If you think about this, the base of our triangle, so base is 6 centimeters, the height is 8, and if we think about this, either thinking about the picture or looking at our net, you might observe we have 4 of these triangles that are identical to each other. Whether you do that as part of this step or whether you just find the area of one triangle, get that answer, and then multiply it by 4, either way is fine. So if we were working this out, you know, one thing we could take half of 6 is 3, and then 3 times 8. 3 times 8 is 24. 24 times 4 would be 96. So for the triangles, we would have 96 square centimeters. And then we'd have our square base. Again, a square is a type of rectangle, so length times width. Length times width, they'll not give you that formula. You need to remember that one. Length and width of our base are both 6, so 6 times 6 is 36. And at that point is just a matter of adding those together. So we want to number our steps to keep things a little more neat. Probably not a bad idea. So 132 square centimeters is our total surface area for that. Example 2, Tamara made a small gift box that has the shape of a triangular pyramid. Faces of the box are identical, equilateral triangles. How many square centimeters of cardboard did Tamara use for the box? Okay, so this is kind of a special type of triangular pyramid. They're actually telling us that all 4 of these triangles are exactly the same. They're all equilateral triangles. So if we look at one of the triangles, you can see the base is 5, the height's 4 and 33/100ths. So we could find the area of one of those, so half times 5 times 4 and 33/100ths. Those are not real nice numbers, so if you wanted to do 5 times 4 and 33/100ths first and then take half of that, remember to get half of something you can just divide it by 2 is a way to get that. So that should be 10 and 825 thousandths square centimeters. That would be for one triangle. And remember, we have 4 triangles that are all identical. So at that point, you can multiply that answer by 4 and that comes out to 43 3/10 square centimeters of cardboard that she would need. So we look at the try it says draw a net, find the surface area of the triangular pyramid. Okay, so once again they did ask for us to draw a net of this. So we're going to have our base in the middle, and then off of that base we're going to have some other triangles. So it's going to look something like this. All of these sides, once again, we have equilateral triangles that are all identical to each other. So if we can find the area of one of these and then just multiply it, we should be in good shape here. So they started off with their formula. Area of a triangle is half times base times height. The base of our triangle is 4. The height is 3 5/10. For this, we could figure half of 4 is 2. And then 2 times 3 5/10. They didn't really give us all of the spaces we might need to work this out potentially. But anyway, if you multiply that, you should get 7. So the area of each equilateral triangle is 7 square meters. And then we have 4 of these that are identical. So I'm not sure why they restated what they just put there, but 4t means 4 times t. I guess they're showing that it's multiplication, which we probably won't use that multiplication symbol there. And then each triangle was 7, so we'll do 4 times 7, which would be 28. So surface area of the triangular pyramid would be 28 square meters. So on page 432, if you look at number 4, each side of the base of a square pyramid is 4 inches, and the height of each triangular face is 3 inches. Draw a net for this pyramid, find its surface area. So we know the base is a square. When we draw a net, we want the base to be in the middle. Generally works better. So I'm just going to kind of look at this. You know, we don't have to count how many squares there are and make it perfect necessarily. Although we want to be kind of close to the middle just to make sure we have enough space to draw this. But so this is a square. It's a 4 by 4 square. That would be the first thing. We just need to draw that 4 by 4 square as our base. Obviously the base of our triangles, the base of the triangles would be 4. The height of them would be 3. So height of the triangles is 3. So if you can imagine drawing these triangles here, we need to draw them so that we have a height of 3. So you got to go up 3 squares right from the middle of your base. And once we've got that drawn, then it's just a matter of finding our surface area. So surface area, we'd have the base would be that square. We'd do length times width, so 4 times 4 would be 16. And then we'd have the triangles. Triangle is half base times height. Our base is 4, our height's 3. And how many of those triangles do we have? we have 4 of them. Once we get to that point, half of 4 is 2. 2 times 3 is 6. 6 times 4 is 24. So we probably don't even need to touch a calculator for this problem. And then once we get to that point, we're just going to add those two together. And that should be 40 square inches. Number 5 is similar problem to what we did on the example there. Just to make sure you know what you're doing with that. You should end up on number 5, 249.6 square feet.